Hello and welcome back to Math with Mrs. Becker. This is Algebra 2 and today we are looking at how to simplify algebraic expressions, and that is section 1.4 in our textbook. So the first thing is being able to go from a word situation into what they call an algebraic expression. And what that means is that you no longer have words. You now have numbers, letters, and symbols. So let's look at this first situation. There are 3 different ways in which a basketball player can score points during a game. There are 1-point free throws, 2-point field goals or 2-point shots, and 3-point field goals, again, 3-point shots. An algebraic expression can represent the total points scored during the game. If you have a variable without a number in front, it is said to have an unwritten one. So just an F for our free throws, that is the same as 1 times F, plus 2 times the number of 2-point shots, plus 3 times the number of 3-point shots. This is a 3 because it's worth 3 points. This is a 2 because it's worth 2 points. This is an unwritten 1 because those shots are worth 1 point. One thing that's really important is as you are converting from words into expressions, you want to make sure that you are aware of what kind of words indicate addition or multiplication or tell you to subtract or divide. So let's go ahead and look at add. Words that would tell you to add. The question might say how many total. The words that I want to make sure you know are sum, plus, and. Okay, lots of times if you are finding the sum of something, the sum means your solution when you add. Lots of times it will say you have 5 red balls plus 3 more. How many would you have total? Or you might have 6 apples and you get 2 more apples. How many would you have? So some of those different words you want to kind of pay attention to and see if you can identify those, and then you know you should add. Multiply. The solution when you multiply is called the product. One of those key words that indicates multiplication is the word of. If you're reading a question, it might say how many altogether. Subtract. The solution when you subtract is called the difference. You might see the word less or less than or minus. The question might say how many more or how many are remaining. Divide. When you divide, the solution is called the quotient. A key word with divide is per. Per means you are dividing. Okay, if you are reading a question, it may say how many are in each group. So you're starting off with a larger amount and you're separating it or dividing them into groups. So here are some examples. They start off pretty darn basic for us, which is a good thing. We're still in the first 2 weeks of school. The number of apples in a basket of 12 after n more are added. So you have 12 apples in a basket and you add n more. There's an algebraic expression. The number of days it will take to walk 100 miles if you walk m miles per day. Per is that word that indicates division. So it's 100 miles divided by m. Or remember, you can always indicate division by writing a fraction. So 100 over m or 100 divided by m. That is the first part of what we're doing for 1.4. Now they want us to go ahead and be able to evaluate an algebraic expression. So what they're going to do is give us an expression that contains numbers, letters, and symbols only, no words. When you are simplifying, it is important to follow the order of operation. You may have heard PEMDAS or please excuse my dear Aunt Sally. This phrase helps you to remember the correct order that you use when you are evaluating an algebraic expression. The first thing you do is see if there's something that you can do inside of parentheses or grouping symbols. Next, you go to exponents. Third is you multiply and divide. Now, multiply and divide go at the same time. You go left to right, just like you're reading a book. Adding and subtracting, that is the last step. But again, they actually go at the same time. they go from left to right. So let's go ahead and evaluate some algebraic expressions. If I have 2x minus x times y plus 4y, first, they will give you a numerical value to fill in for each variable. So what they want us to do is replace every x with a 5 and every y with a 2. So if I have x times, or 2 times x, which is really a 5, minus x, which is a 5, times y, that's a 2, plus 4 times y. So notice I had 2 x's in the problem, x is a 5, I replaced both of those x's with that value. Y's, my y is a 2, so I have 2 values, or 2 locations where I had to change y to a 2. Order of operations, there's nothing I can do inside of parentheses. All of my parentheses are just when I filled a value in, so they indicate multiplication. I have no exponents, so I'm going to go ahead to the next step, multiply and divide left to right. 2 times 5 is 10, minus 5 times 2 is 10, plus 4 times 2 is 8. Add and subtract left to right. 10 minus 10 is 0. 0 plus 8 is 8. Done. Okay, so we just evaluated an algebraic expression. Let's look at another one. Step 1, replace all of the r's with 3 and replace all of the q's with 7. So I'm going to go ahead and do that. So I have 7 squared plus 4 times q, which is really a 7, plus times r, which is really a 3, minus r, which is really a 3 squared. So I have 2 q's, the q's became 7s. I had 2 r's, the r's became 3's. Order of operations, yes, I do have parentheses, but within the parentheses, there's only one value. Okay, so this is multiplication. Exponents, 7 squared is 49, plus 4 times 7 times 3 minus 3 squared is 9. So I have no parentheses. I did the exponents. Now you multiply and divide left to right. So I have my 49 plus 4 times 7 is 28 times 3 is 84 minus 9. Now you add and subtract left to right. So 49 plus 84 is 133 minus 9 is 124, and you're done. So replacing the variables with their numeric value, then you go ahead and use the order of operations until you have it simplified down to one value. Let's look at one more. Turn all of the x's to 2, turn all of the y's to 5. So 2 squared times 5 minus 2 times y squared plus 3 times y. Again, I had 1, 2, 3 y's, so there's 3 locations where I had to fill in that value of 5. 2 x's, so there's 2 locations where I had to replace the x with a 2. Order of operations, there's nothing I can do inside of parentheses. All of my parentheses are one single term. Exponents, 2 squared is 4, minus 2, 5 squared is 25. So I went ahead and I did the exponents. Now you multiply and divide left to right. 4 times 5 is 20, minus 2 times 25 is 50, plus 3 times 5 is 15. You add and subtract at the same time, left to right. So 20 minus 50 is negative 30. Negative 30 plus 15 is negative 15. It is okay to have a negative value. The next thing, if you are simplifying, so far we have written algebraic expressions, gone from words to numbers, letters, symbols. Then we evaluated algebraic expressions using the order of operations. Now what we're going to do is simplify. When you are simplifying, there are 2 rules. Rule number 1 is no parentheses. If you have parentheses, you need to use the distributive property from chapter 1, section 2 to cancel parentheses. Then what you do is you combine like terms. Now, like terms are terms that contain the same variable with the same exponent. So here, 3x squared plus 4x squared, those are like terms. When you combine them, you will not change the x squared. What you add are the values in front. So here, they both had an x squared. The x squared remained. 3 plus 4 is 7. Constants are also like terms because they have the same variable. Their variable is that they don't have one. This doesn't have a variable. This doesn't have a variable. So they are like terms. They're called constant terms. I can combine them. Positive 2 plus a negative 1, that's a negative 1. Now this term I would not be able to combine with anything because no other terms contain one x and one y. Okay, so that is how you combine like terms or identify them. One little helpful hint, if you ever have a variable without a number in front, it has an unwritten coefficient of 1. So if I have y and I'm going to combine it with another y, this is the same as 1y. Let's keep on going. If I want to simplify the expression, simplify, there are 2 steps. Step 1, no parentheses. I have no parentheses here. Step 2, combine any like terms. This term has 2 x's because it's x squared. This term also has x squared. So I can combine them. 3x squared plus 4x squared gives me 7x squared. Then I have a 2x and a minus 3y. These are still part of your solution. You just did not change them because you couldn't combine them with any other term. Okay, the next one, notice I have j's and k's. If you have 2 variables, you always want to make sure that you write them in alphabetical order. That is why the j comes before the k. When I am distributing, because step 1 is cancel parentheses, I am giving each term 1j. So it's 6jk squared plus 7jk. The j has to come first because it's first in the alphabet. Plus 9jk squared minus 7jk. Now notice this j only went to these 2 terms. It can only get brought into the terms that are in parentheses. It does not change the terms that were after the parentheses. Now I combine like terms. This term has 1j and 2k's. This term has 1j and 2k's. So I leave the j and the 2k's. What you change are the numbers in the front. 6 plus 9 is 15. This term has 1j and 1k. This term has 1j and 1k. So the jk's don't change. What you look at is the numbers in front. Positive 7 plus a negative 7. Remember from 1.2, if you add opposites, you get a 0. So positive 7jk and negative 7jk would completely cancel, leaving you nothing left. One more problem like this. Step 1. If you have parentheses, you need to distribute first. Here, you remember, you multiply the numbers together. Negative 3 times 2x is negative 6x. Negative 3 times a negative. Negative times a negative makes it a positive 3xy. Negative 3 times a positive 3 is a negative 9y. Minus 11xy. Remember, this negative 3 only goes to the 3 terms in parentheses. It will not change your negative 11xy. Next step, you look for any like terms. This term has an x and a y. This term has an x and a y. You can combine them by just combining the numbers in front. Positive 3 plus a negative 11 is negative 8. This term is still part of the answer. This term is still part of the answer. It does not matter the order that you wrote this. So if you put negative 9y minus 8xy minus 6x, you're still correct. As long as you have a negative 8 in front of the xy, a negative 6 in front of the x, and a negative 9 in front of the y. The order that you write these is not important at this time. All right, let's go ahead and look at some, oh, I love these, okay? Some good story problems. Apples cost $2 per pound, and grapes cost $3 per pound. Write and simplify an expression for the total cost if you buy 10 pounds of apples and grapes combined. Now, here's the deal. I cannot say $2 for apples and $3 for grapes because I do have this limitation. Your limitation is you are only allowed to buy 10 pounds. So I could say $2 times however many pounds of apples and $3, but grapes is going to be 10 pounds minus apples because it's 10 pounds is how much you buy total, minus the amount of pounds of apples you bought, that's how many grapes you would have left. So here's what your statement would actually be. $2 per pound of apples plus $3 per pound of grapes. The amount of grapes is your $10 total minus how many apples you got. Now I can distribute. So 2a plus 30 minus 3a. Combine your like terms. So I have negative a plus 30. There is your expression. What is the total cost if 2 of the 10 pounds are apples? So A represents apples. So I replace A with the 2, so negative 2 plus 30, your total cost would be $28. Okay, and here's one more, just in case you're like, what the heck just happened? Okay, a travel agent is selling 100 discount packages. So there's my limit. He might be an amazing salesperson, but the company's like, yo, dude, you can only sell 100, okay? So he can sell 100 discount packages. He makes $50 for each Hawaii package that he sells and $80 for each Cancun package, okay? So he's making some pretty hefty commission. How much will he make if he sells 28 Hawaii packages? Okay, so again, we have $50 per Hawaii package plus we can't say 80 Cancun because we have this limitation. If they just said, hey, straight up, he makes 50 for every Hawaii package and 80 for every Cancun package, you could do that. You go 50H plus 80C. But they said he only gets to sell 100. So your $80 for Cancun packages, the number of Cancun packages he sells is the 100 total minus how many did he sell to Hawaii. Go ahead and distribute. So 50H plus 80 times 100 is 8,000 minus 80H. Combine your like terms. 50H plus a negative 80H is negative 30H plus 8,000. How much will he make if he sells 28 Hawaii packages? So H is 28. So negative 30 times 28 plus 8,000. Let's go ahead and plug this in. Negative 30 times 28 plus 8,000. Holy smokes, that's pretty hefty. $7,160 would be the commission that travel agent would make. So super cool. That is 1.4, my friends. Your assignment to work on over the weekend is 1.4 assignment. It's worksheets A and B. There are a lot of spots where the worksheet does not provide enough space to work, so please feel free to do your work on a separate sheet of paper. Hope you're doing well, and I'll talk to you soon.